Hi everyone. Hi everyone. My name is Karthik Kumar Reddy and I am from CSC A section from VVIT. My number is 551. Today I want to discuss about fixed variable partitioning in operating systems. Yeah, the fixed in memory, the is also known as static partitioning, and variable partitioning is also known as dynamic partitioning. Yeah, contiguous allocation. Contiguous means continuous allocation. An execution process must be loaded entirely in main memory. For execution any program, it must be loaded into main memory. Main memory is usually split into two parts. Resident operating system. In one part, there is operating system. Our OS will be there in one part, and user processes will be in the second part. The low memory partition will be there in residential operating system, and the user process there will be high memory partition. Relocation registers used to protect user process from each other and from changing OS code and data. Contiguous allocation means continuously real memory management techniques. Although the following simple basic memory management techniques are not used in modern operating systems, they lay the ground for a later proper discussion of virtual memory. That is, these are the real memory management techniques. That is, fixed or static partitioning, variable or dynamic partitioning, simple or basic phasing, simple or basic segmentation. These are the four types real memory management techniques. Fixed partitioning. Partitioning main memory into set of non-overlapping memory partitions. In fixed memory, there will be no overlappings, and fixed partitions can be of equal or unequal sizes. Again, the fixed partitioning is divided into two types. That is, one is equal type and is unequal type. Leftover spaces in partitioning after programming assignment is called internal fragmentation. This is important. The spaces that are left in after programming assignment, after the allocation CPU, after memory is allocated, the leftover spaces is called as internal fragmentation. Here in the diagram you can see two diagrams. That is equal partitioning and unequal partitioning. In equal partitioning, all are taking same memory size. Operating system item, we and the remaining process 1, 2, 3, 4, 5, 6. These remaining sub process also take same eight memory. Whereas when you take the operating system, that is unequal size partitioning, operating system takes 8 MB and remaining partitions also are of different sizes. First one 2, second 4, 6, 8, 8, 12, 16, and these are all of different sizes. This is unequal operating system. Unequal partitioning. So I'm sorry, that's unequal partitioning. Placement algorithm. Equal size partitioning. If there is an available partition, a process can be loaded into that partition. In equal size, all the partitions have same size. If the process of the is can be loaded on that in that size, the process is loaded. Because all partitions are equal size, it does no matter which partition is used. That means the process can be loaded in any of the equal sized partition. If all partitions are occupied by blocked process, choose one process to swap out and make room from the new process. If all are blocked, all the memory is filled. If process want to execute, one will be blocked one process will blocked and taken out and swap and the new process enter into that place. Yeah. Unequal size partitioning. In unequal, this is something not really close to equal size partitioning. In unequal size partitioning, the operating system is divided into different the memory is divided into different parts of different sizes. The first part is operating system in memory, main memory, and remaining are if the process is the process which is near size to the partition is loaded into that partition. Unequal size partitions uses of multiple queues. Assign each process to the smallest portion within which it will fit. For example, if you take there are three process 100, 150, three partitions 100, 150, 200. If the process is 9, if process size is 90, it will fit into two, the 100 MB partition and 150 MB partition. But it will be taken into 100 MB partition because loaded into 100 MB partition because it is well fit into 100 MB. Where only wastage is 10. Whereas if you fit in 150, the wastage will be 60. That is the process in unequal. So by unequal partitioning, there can be some internal fragmentation will be reduced than the equal size partitioning. That is about unequal size partitioning. A queue exists for each partition size. Here there are some partitions from of different sizes. A queue will be there for each partition size. Try to minimize internal fragmentation. Problems. There is some problems with unequal size partitioning. Some queues might be empty while some might be loaded. Dynamic of fixed partitioning. Any process whose size is less than or equal to partition size can be loaded into partitioning. If all partitions are occupied, the OS can swap the process out of the partition. A program may be too large to fit into partition. The programmer design the programs with overlays. Comments on fixed size partitioning. Main memory use is inefficient. Any program, no matter how small, occupies an entire partition. This can cause internal fragmentation. In fixed size partitioning, internal fragmentation is there. That is the main disadvantage of the internal fixed partitioning. Unequal size partitions lessens these problems, but they still remain. In unequal partition, some internal fragmentation may be reduced, but the problem will be there. Equal size partitions was used in early IBMs. And equal size partitions were used early, multi-programming with fixed number of tasks. It's not used nowadays. Yeah, that's about the multi-programming with a fixed number of tasks. Thank you. Thank you, Anand.